All right, hello everybody. Can you hear me okay? Sweet. Really cool to be doing this in person. Again, it's been a long time, so I appreciate everybody coming out. This is pretty cool to do this in a theater as well. So my name's Kyle. I've been doing threat detection and incident response for about the last 10 years. I've been doing it in all sorts of venues, from Cyber Command in the U.S. Air Force to the tech industry, most recently at Box, building and managing the detection engineering team there. I currently work at Panther Labs as a security engineer. I've been there about a year or so. So we are a SIM vendor, so I want to just start with this disclaimer. This is not a vendor pitch by any means. Detection as code is one of those sort of core concepts in threat detection and threat detection management where you can apply it to sort of any tech stack that you have in your environment. There's maybe 5 to 10% of this that will get a little tool specific, but I don't want this to become a vendor pitch, and it's not going to be. So why are we talking about this? So if you've been in the threat detection or incident response landscape, you've probably seen this term before. It's probably not the first time you're seeing it. In the last 3 or 4 years or so, we've had industry practitioners, thought leaders, and vendors starting to talk about detection as code. Should we do it? Does it matter? Yes, we need to do it. Use my product to do it, that kind of thing. And then more recently, we've seen practitioners, security engineers, and analysts start to say, hey, here's how this works in my environment, and here's how it helped me. And I have the same experience at Box, and I want to share that with you. And so, really what's been changing over the last 4 to 5 years, right? So threat detection or detection engineering 5 years ago was a pretty specialized field. You had to be at a pretty big security company or a company with a pretty big security team and maybe a pretty advanced security team to have a dedicated threat detection function. And then over the last 4 or 5 years, we've started to see, a lot more detection engineering posts on LinkedIn, people looking for detection engineers, smaller companies or companies, security teams of any size, building out threat detection functions because of the importance of writing threat detection specific to your environment, right? And having the ability to build and maintain that detection logic that's very specific to how your company works or how your product's built. So why are we okay, great, all of that's happening, but why? And this is the most profound slide of my entire presentation. It's because it's hard, right? Anybody who's done it knows that, and when I specifically wrote this term, I was thinking writing the content is hard. It's hard to research the threat. It's hard to understand how I see that in a log. It's hard to understand, how to write the logic so that I only pick that piece up. And all of that process of building the content is extremely hard, but that's not what we're talking about today. So today, we're going to be talking about a totally different set of problems for threat detection. Content aside and threat research aside, those are all very hard problems as well. So what are some of the other problems around threat detection, or what makes it hard to do in a sort of modern, scaling security team? And I'm sure many of you have asked these questions before, had them asked to you. So who changed, detection X and what changed? It sounds like an easy question to answer, but depending on where your detection lives and how you maintain it, it may not be that easy. Am I going to introduce errors? Am I going to introduce problems or false positives, ticket cannons by making a change or releasing this detection? I don't know. It can be hard to understand that or answer that question repeatedly. When will we have a use case completed? New threat comes down the line. Where does that fall in all of the work that we're doing from a threat detection standpoint? Is it still working as expected? And we'll go in deeper into that as well. Is the current version of my logic running? Did it get saved in my SIM appropriately? Like I said, ticket cannons. Am I going to deploy a detection that just generates hundreds of alerts that are useless just right off the bat? Definitely done that several times. And then this is the most important to me, and why detection as code really hit home for me when I first started kind of learning about it, is like thinking about, as a detection engineering team, thinking about what you're producing as a product to whoever's responding to that alert. It may be you, or it may be a dedicated team. And thinking about how can we improve the product for the incident response team, and what are the processes and technical guidelines or technical guardrails that we can wrap around the process of threat detection sort of creation to produce the best product that we can for the incident response team. Lowest amount of false positives, highest amount of signal. So I mentioned the term a lot. Let's define it. So detection as code to me and to a lot of others, is applying software engineering principles and best practices to writing threat detection. So, right, software engineering has been around for a long time. They figured out how to write good, consistent code. They figured out how to test it and how to do things repeatedly and reliably. Threat detection, we're kind of just stepping into this space. You know, a lot of days of copying and pasting detection into the production version of your detection logic. Those types of things that software engineering figured out 40 years ago, we're just starting to think about in threat detection as we consider this more of an engineering discipline and need to apply more rigor to it in order to create that product experience that I was talking about. So that's really how I define it broadly, and kind of how we'll think about it going forward in this presentation. So I categorize it into 5 domains, sort of like the 5 domains of detection as code. And I have these ranked up here in sort of the order of ease of implementation. So starting with things like process and ways that you can think about writing detection in your SIM a little bit differently than maybe you are now, all the way down to integrating your SIM with other tools, integrating with version control, integrating with CI/CD, and really thinking about a test-driven development approach to threat detection. So let's start with Agile. This is nothing groundbreaking here, right? Everyone's used Agile, but thinking about it from a threat detection standpoint, we can answer some of those questions that we talked about before. Having a prioritized backlog, the team constantly knows what they should be working on. It's always kind of that up next mentality of here's what we've decided is the most important. Next, we're going to work on that. And that obviously changes over time. But dedicating time for documentation, testing, and review in your workflow process for the team. So having, or yourself, I say team, and all of this is interchangeable, just to make that clear. This doesn't need to be a team of detection engineers. It could be one person writing detection, but thinking about these things as sort of important components to building any type of threat detection. So dedicated time to documentation, testing, and review, and then being able to monitor, work in progress. Are we trying to do too many things? Is the work that we know we need to do, does it keep getting deprioritized by, the latest, greatest threat that may or may not be that relevant in our environment? Some great resources here, one from Alex Teixeira and Palantir around documentation and Jira workflows. Okay, so this is the 5 or 10% that I talked about that may be pretty specific, and it's specifically around using expressive languages. So most query languages, right? You can look for an IOC, you can look for something pretty generic, pretty easy to do. That's right. Any security tool or SIM will do that for you. But where we start thinking about trying to do more complex functions, import third-party libraries, really tailor that detection to your environment to reduce that false positive ratio, we need the flexibility. An engineer needs the flexibility, right, to be able to express what their desire for the threat detection logic into what they're producing. And I'll go a little bit into this in just a second, but having the ability to do that in the language that you're writing is a very powerful feature. Some of these others, these are very SIM agnostic, right? So turning common components or pieces of the detection logic that is the same across many use cases, turning that into a function or function. There's many sort of pieces within a SIM that will let you do that. Lookup tables and data models, those are other great ways to sort of centralize data or centralize functionality into a single place and then be able to just call that any detection use case that you're writing. A data model is obviously being able to write a single detection across multiple log sources. That is sort of like code reuse at its finest right there. So this is what this is Yara L. So this is an example of this is pretty simple, right? I just need to check if IP is in a CIDR range. That's pretty simple. But some languages don't let you be expressive like this, and being able to just say write this in one line as a detection engineer or someone maintaining detection is really great to be able to do, and makes it very readable, and on and on. This is a Python example, so just another example of sort of the functions that I was talking about, but being able to define a function and then call it repeatedly. I blurred some of this other stuff out because it's not important. But the important part, right, is being able to define that piece of code that you're going to reuse in a single place, maintain it in one place, update it in a single place. All right, so this is where it starts to get more fun and more interesting. So the next three pieces, if we start thinking of them as a house, I would say version control is the foundation to this house. And it is kind of the core component of being able to run CI/CD workflows and really implement test-driven development. So probably fairly familiar with the benefits of version control, right? So one of the benefits that I really saw and that I really appreciate is being able to easily pick out what's changed in a peer review and easily being able to enforce that peer review. So when we go back to thinking about detection as a product, having that peer review, having it validated, having the change validated, and as a leader that's technically enforced, that is a great feature to have to make sure that you're having eyes on detection and eyes on changes as they're being made. One thing I want to explicitly call out here is sort of the flow and where version control needs to fit into the workflow. So basically, it needs to be pushing your detection to your SIM, right? It needs to be the source of truth, because that starts to let us enable these things we're going to talk about next about CI/CD workflows and testing. If you're pushing things the other way, right, you're basically just doing a glorified backup from the detection logic in your SIM into your version control, and you don't have that enforced peer review. You don't have the changes being flowed through version control, and you kind of lose the benefit. So not to be dramatic, but I think doing it that way is a bit of a glorified backup, and it needs to go the other way. And that's really important for what we'll talk about next. So CI/CD, if we think about software development, infrastructure as code, you're writing tests, you're doing linting, and you're making sure that your current version is always in production. And we can think about those same concepts for detection logic. So CD, ensuring that as I merge a change into the main branch, it's always being pushed into my SIM, and I always have the most up-to-date version of my logic in my SIM, and there's no question about it. We can enforce testing, which we'll talk more about here in a second, and then also do some cool stuff with linting. So linting is kind of an easy step to kind of improve pieces of your detection workflow without doing full-on testing, because full-on testing can be difficult to automate or do in a CI workflow. By doing linting, so just an example, one of the first use cases that we used for linting detection logic was looking at metadata. We used to have metadata fields in detection logic that populated in tickets and helped track metrics. And so we wanted to make sure that those were always there. When maybe someone new came onto the team, they didn't quite have all the pieces in place and didn't understand exactly what needed to go in there from a metadata standpoint, we had no way to technically enforce that. But we could write a linter to say, hey, as this is going through CI, check to make sure that these fields exist, or this string exists, this metadata is filled out. And so you can take that you can run with that pretty far, looking for maybe functions that you are expensive in your SIM that you don't want your detection logic to be using. Even making sure, simple things around metadata, making sure the scheduled search is scheduled on an interval that you expect. You can really enforce a lot of technical controls just with linting to make sure that the detection is sort of like structured from a metadata standpoint or even from a logic standpoint in the way that you want. All right, so leading into the last piece. So I think everyone's been here too. You had a pen test or a red team exercise. They did X, X action. You're like, wait a second, I wrote a detection on that, a couple months ago. This isn't possible. Surely we detected it. You didn't. And you look and you find out why. It's because something was broken, right? Something changed. Maybe the schema changed. Maybe there's a change in the environment that you didn't account for. There's a number of things that could go wrong there. And the goal of test-driven development is to try to reduce the number of occurrences where that happens, because that's super demoralizing for like responders and detection engineers. So the concept of test-driven development is a software engineering concept. Basically, you write your test cases before you write the actual code. And so when I first came across this, I was like, that's kind of weird. How does that apply to threat detection? And if you think about it, when you're building detection logic, you're going to look at log events. Those log events are our test cases. So whether that's a log event that you expect to generate an alert or a log event that you don't expect to generate an alert, those are two test cases that you can use going forward. I would say the difference, at least in my experience in threat detection, we take those test cases, we build our code, or we write our detection, and then we kind of like throw them away. They're like gone. And we just expect it to work forever when that's not necessarily the reality. So the goal here of some of these workflows is to keep those test cases around and keep validating that changes to logic, that changes in the environment aren't affecting your detection coverage, and you're getting the detection coverage that you expect because you worked hard to build it, and you want to maintain that. So this is really where everything starts to kind of come together. And I will say this can be difficult. There's a couple different ways to go about testing detection, and especially trying to do it in an automated way. So the first one is statically. So this is basically the idea of just taking those log events and passing them through the detection logic and confirming whether or not the detection still works. So this is good for validating that changes you've made are going to break the logic. Ensuring that everything across the board is still working as expected. There's a downside here, right? Because it doesn't account for the environment. You're having these sort of like statically defined cases. If the environment changes, I don't know that in my static test case because it didn't get updated and it might not reflect what's happening in reality. So that's where these other two come in. So we have sort of like dynamic and then what I'll kind of call continuous, but you can kind of almost think of these as the same way, just sort of implemented in two different ways. So the idea behind, and they actually kind of go together, to be honest. The idea behind dynamic testing is running the search and looking for events, looking for true positives and making sure that we're not getting false positives. And so this would be basically you're testing this against real data in the environment. And then the challenge becomes, how do I get those true events, right? How do I get those events that I know should be triggering the detection? How do I produce those? There's a variety of frameworks out there. So you have like the Atomic Red Team framework. You have the MITRE Caldera, which does some of this like adversary emulation. And trying to tie these pieces together in order to be able to generate live test cases in the environment and then validate that the detection caught it. And like to be completely honest, this is something that I wanted to build out and I haven't been able to yet. So if you're doing something like this, I would love to hear about it, but I think that this is the standard that we need to get to when we start testing detection and thinking about how we validate that detection is functioning going forward. So it's a high in the sky goal, but I would love to do it for real. So yeah, some links here around sort of Red Canary, the Caldera framework, and a couple other things as well as it relates to testing. Cool. Did we solve these? Let's find out. We got pretty close. So like version control, CI, and testing helps a lot with answering these questions. And as do Agile workflows around processes and product improvement. So Cool. I mean, one thing or a couple things I want you to take away from this too is this is very sort of like environment agnostic, team agnostic. No matter the size of your team, you can start to think about implementing some of these workflows if you're not, and kind of like molding them to your environment. They don't need to be, structured in the exact way that I described here, but it's all about sort of like the high level concepts and how do you apply that to how you're building threat detection in your environment. So, cool. I'll be around the rest of the day and at the Panther table as well, so please drop by for any questions you want to talk threat detection or anything else. I appreciate everyone coming.
Thank you again for presenting at BSidesSF. Again, Kyle Bailey, and this is from Maltego. Thank you. Thank you all for joining us as well. Thank you.